Hey Math 8 students, this is Misty Witt again. Today we're going to be doing a math notes on proportional relationships. So you're going to need your toolkit, a highlighter, and maybe two highlighters actually, and a pencil. Go ahead and open your toolkit to page 7. The title is Proportional Relationships. We're going to start by highlighting the first paragraph. So proportional relationship can be seen in a table and on a graph. So the table has where one quantity is multiplied by an amount, the corresponding quantity is multiplied by the same amount. So we'll look at that at the table below, but just keep that in mind. A proportional relationship on a graph is linear and it goes through the origin. So let's keep those two things in mind as we look at what a proportional relationship example looks like. So in this example, we have pounds of chicken that 3 pounds of chicken cost $7. So it's important to notice that 0 pounds of chicken costs $0. That is basically passing through the origin. Also over here, do you see how it goes through the origin? So that's one factor. The second factor of a proportional relationship is that it increases or decreases by the same amount. So in this case, all of the pounds are increasing by a constant rate of 3. And as it's increasing by 3 pounds, the cost is increasing by 7. So as long as those are consistent all the way through, that tells us that this relationship or this example is linear. So yes, it is linear, and we can double check that by looking at the graph. I noticed that this graph is a straight line. So that tells me it's linear because linear means it's a straight line. So let's take that note so we have that. I don't know why there's that little extra parentheses there. And then we noticed here that at 0 pounds it was $0, and on the graph it's passing through the origin. So that's the second criteria for a proportional relationship. Passes through the origin. The origin is where you have two axes that meet. So the x value is 0 and the y value is 0. So they give you a proportional relationship, but they're also going to give you a non-proportional relationship. So I'm going to change my highlighter color because this is an example of a non-proportional relationship. I noticed that as the games are increasing, so the games all increased by 1 every time, and the cost increased by 1 also. So that told me this was linear because they were all the same. And then I looked here and I saw that this graph was going straight. So that told me it was linear also. I'm not going to connect the points because it's not continuous. But this example is linear. The only reason that makes it non-proportional is the fact that it's not going through the origin. Actually, let me change that color. The fact that it's not going through the origin makes it non-proportional. And also, if you look over here on the table, it doesn't start at 0, 0. So if you're playing 0 games, it's still going to cost you $5. That's not proportional. So that is what makes it non-proportional. Does not pass through the origin. If it had passed through the origin, this example would have been proportional. So those are the two criteria, that it passes through the origin and that it's a straight line. It's linear. Let's take a look at one more example of a proportional relationship and one more example of a non-proportional relationship.